Greetings. My name is Sean, currently a fourth year in mechanical engineering, Curtin University, Malaysia.
Hello everyone, my name is Casper. I am in my fourth year semester 1 of mechanical engineering.
Hello, my name is Edison Lau. I'm currently fourth year semester 1.
Hello, my name is Samuel Chen Gawei, and I'm currently in my fourth year final semester of mechanical engineering.
Hi, I'm Novin from Mechanical Engineering and currently is year 4 semester 2.
Kuching, the capital city of Sarawak, Malaysia, is widely known as the Cat City, a title that originates from the Malay word kucing, meaning cat. Although Kuching is rich in cat-themed imagery, most of these elements are static and decorative, serving primarily as photo opportunities rather than as interactive or educational features. This presents a significant gap in how the city's cultural icon is experienced, particularly by younger audiences. Our objective was to design and build an interactive cat sculpture that would do more than simply enhance its surroundings aesthetically. To better understand user preferences and gather design input, we conducted a survey targeting students and staff at Curtin University, Malaysia. The survey received 100 responses via Google Forms. Based on the emphasis on aesthetics and minimalism highlighted in the survey, the sculpture will be designed with clean, simple lines and a form that is both playful and elegant. Since motion detection and physical interaction were identified as the most preferred modes of engagement, the design will incorporate ultrasonic sensors and servo motors to enable responsive movements. This 3D model shows the sculpture positioned on a rotating circular base enclosed by a semicircular display table. In addition to the 3D model, we have produced detailed 2D technical drawings to support the fabrication and assembly process. The sculpture is intended to feature 3 primary mechanical functions: a rotating base, a wagging tail, and an extendable front paw. All 3D printed parts will use PLA. The rotating base is a pre-made plywood component. The U-shaped table will be laser cut from plywood, and the supports will be made from acrylic boards. The design process began with a series of conceptual sketches, where the team explored various ideas to give the sculpture a distinct personality while staying true to the theme of Kuching, the Cat City. Once a general concept was agreed upon, the team transitioned into digital modeling using Fusion 360, where detailed CAD models were developed. The cat sculpture begins with a continuous base rotation driven by a motor. An ultrasonic sensor on the front detects nearby objects and halts the rotation. The tail then gently wags for about 2 seconds, followed by the paw extending forward via a servo to push the object. Once the interaction ends, the paw retracts and the rotation resumes. Now, let's take a look behind the scenes at how the sculpture was brought to life. First, we present an exploded view animation that illustrates how each component, from the outer shell to the internal supports and electronic parts, fits together within the final structure. The motion simulation demonstrates that the rotation of the base and the wagging of the tail are both driven by servo motors. The paw extension system operates through a series of rotating gears that drive a wheel connected to a coupling rod. As the wheel rotates, it moves the coupling rod, which in turn causes the paw to extend and then retract during one full rotation. In addition, we feature a stress analysis animation based on finite element analysis, which was conducted during the design phase. The analysis focused particularly on the front paw and the base. This helps evaluate the structural performance of key components under load. In conclusion, this project successfully brought together creativity, engineering, and cultural inspiration to develop an interactive cat sculpture that reflects the spirit of Kuching. Looking ahead, future iterations could explore additional interactive features, such as sound or light responses, enhanced durability for outdoor environments, or expanded motion sequences to further enhance user experience. All these achievements would not have been possible without the dedicated efforts of each team member.